So far, we have covered. I just told you what is a foreign key, but we didn't touch more upon that. But we completed all the create table, lateral table, drop table commands. And I also showed you about the different types of constraints, table level constraints, row level constraints. And we also looked at them. So we'll also look at some of the create table commands today. Wanted to cover them last class, but we didn't get time. So I'll show you some and then we'll try looking at all the what do you say, constraints and and I'll also we'll discuss about the other types of keys as well. Foreign key, composite, alternate, and why we need a foreign key, why tables are such that why do we need to have foreign keys? And then we'll look at joins. We'll see what are the different types of joins and how do we use them, why they are useful. Okay, cool. Let's start. So I think we covered all the way till primary key. So we were waiting. I just explained briefly what is a foreign key, but we'll try to see why we need one such. Okay. Let us say you have a table. Okay. So I had a table of authors. So we are in a library and we had a table of author. So one is name of the author. Let's say name is Chetan Bhagat. And let us say we had some other information about him, city, and let's say we had books. Chetan Bhagat city, let's say New Delhi. So initially he had written only one book. So let us say the name of the book is um, what is it? 5 point someone. So let us say I want to add one more. Let's say Chetan Bhagat writes one more book. Say we have a ID here. Chetan Bhagat writes one more book, and the name of the book he wrote a second book. That was two states. This is also written by Chetan Bhagat. So same. This will also be same. After some more years, he came back. He wrote one more book, Three Mistakes of My Life. So if he has written 3, 4 books, that is fine. But once he starts writing 100 books, what is happening? So the name is common everywhere, right? The name is common. The city is common. Let us say instead of this, we also add some more information, like we also had the email ID of the author. Okay, so then the email ID also would be same. Email ID cb@gmail.com. Okay, forgive my handwriting. cb@gmail.com. So now across these tables, all this information is repeated, right? This is repeated, 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 this is repeated. So one is we don't want to repeat information. Why we don't want to repeat information? Wastage of storage, right? One is waste of storage. And also, what is the other issue? So tomorrow, let us say what happens is Chetan Bhagat loses his access to Gmail. So he told some controversial statement, government came and blocked his account. So now he changes his email provider and he becomes CB at the rate instead of Gmail. Let us say he goes to yahoo.com. So now, because in this table, these are different things. In this table, Chetan Bhagat had so many books, and in front of every book, the email was written as what? The email was written as cb@gmail.com. So now what will I have to do? I have to go to all these columns, sorry, all these rows, and then change the email ID, right? So unnecessary writes. I know the only one information has changed. What has changed? the email ID of Chetan Bhagat. So, but even though only one information has changed, and and I have to go and update it at lot of places. So again, this is what do you say, extra work, right? So that is why we have to come up with something with which we can say, if I update something, I don't have to keep worrying about if something changes, I don't have to keep worrying about updating it lot of places. Okay, so this is one thing. What other things will be problematic? Okay, so let us say Chetan Bhagat. Now we also want to store how many books he has sold. Okay, then what I'll do? I'll start coming and adding here one more row, that is books sold. Okay. Then let us say afterwards somebody comes and says, I just don't want to see the number of books he has sold. Somebody comes and says, I also want to see how many people have subscribed, how many people have bought this book online. So let's say we become bought online. And afterwards somebody says, I also want to know the address, Chetan Bhagat's address. Okay, so I'll come and add address here. Again, after sometimes we come to a situation where we have to add, let us say, some other information related to the author. It can be to which all newspaper he is associated. Okay, so then what happens? Now, lot of things I'll have to repeat, right? So let us say for one book sold online, I'll give some number, 100. Book sold offline, let's say it is what 200. His address is so and so, so and so, so and so. Now, because this column is present everywhere, I have to add his address everywhere. Same data is getting repeated. Okay. Here also, here same data won't repeat, but if the book name comes again somewhere, the same data is getting repeated. So what can we do? There should be some way through which we can map the data from, we can divide the data into different tables. So let us say one table is just for information about the author. So books sold should not come here, or books written by the author should not come here. Information, I mean strictly information. So let us say then what I do, I create a table. Now I do like this. So one is author ID, let's call it AID. So AID is one, name of the author, Chetan. And then his phone, his email. Okay. And then here I'll have, let us say his address. Okay. So now his email was cb@gmail.com. Let's say we also have Amish Tripathi. Amish. Okay. So he's am@gmail.com. So when I'm wanting to see what all books they have written, I'll create a separate table called books. Okay. So in this books, what I have now, I have book ID. So BID, I'll call it. Okay. So book ID one, let's say title is what? 3 mistakes of my life. So here, instead of writing everything about the author, I'll just write the author ID. Okay. So author ID will become what? 3 mistakes of my life written by Chetan Bhagat. So I write author ID as one. Okay. So now I've done this. And here, let us say I write publisher. Publisher is, let's say, spring publication. Okay. So even for this, we can add, we'll do a little bit afterwards. But for now, understand publisher is spring publication. So let us say now what happens is, now I want to change email ID of Chetan Bhagat. So how many places will I have to make changes? I'll have to come here only. Only one particular place I have to make changes. Because at all the other places, what have I included? I've just included a number, the author ID here, right? So I've just included a number which is pointing to this table, and I can easily fetch information on the go if I need at any point in time. Okay, how we fetch that information, that is done using joins. We'll discuss joins a little bit further. But for now, we need to know that what are we achieving here? We are not repeating data. right? Because I have put the data related to information at only one place. At any point of time, if I have to find the data related to the author, I'll just see and come and search in this table. Okay, author ID 1. So who has author ID 1? Chetan Bhagat has author ID 1. Okay. So now uh, this author ID does not actually belong to this table. What do I mean by does not actually belong to this table? So this is just like it is only a reference to this table. It should be also present somewhere else. That somewhere else is here. So that is why this key is called as foreign key. Okay. So this is foreign key, and to which table this belongs? It belongs to this table. So at any point in time, I cannot add, let us say I add book number 3, book number two is uh, what book? So let us say it is data structures and algorithms. Let us say it is written by author ID 3. Okay, and it is published by O'Reilly. So does 3 exist here? Do I have somebody with author ID 3? No. So since I don't have anybody with author ID 3, this is wrong. I cannot add this thing. So what MySQL does is it checks. So at any point in time, whatever I'm inserting into this, it should be present in the table from which I'm referencing. Okay. So now if I was going to add, let's say 2, and I was going to add Sion of Ikshiwaku. Okay. And then if I add 2, no, then it will say okay. Because this this author, right? This author ID 2 is present in this table. So this way now I can add as many books as I want. Let's say one author writes 100 books. No, I'll add 100 columns here. But I don't have to at any point in time repeat the data related to the author. Okay. And also the number of columns is not excluding. Only whatever information is necessary that is present in that particular table. Okay. So this is why we have the concept of foreign key, and why we are breaking the information between 2-3 tables instead of having everything in one single table. One is we won't waste more space, more storage. The other one is if you want to update anything, it should not become very difficult. We want to update very quickly, and we want to only update the places, minimum updates, so that if you change something, you should not go and do it everywhere, right? So that is one thing. And another one thing is we want to keep only related data together, right? So data related to author should be in one place. His books data should be in one place. We should not combine everything in one place only. They should be separated. Okay. So a foreign key is a column or set of, so it need not necessarily be one column only. It can be more than one column. So, and what is it used for? It is used to establish a link between two tables. Okay. So what and ensures referential integrity. What do I mean by referential integrity? It means whatever data we are using in this table, which is being called from another table, like reference from another table, it is present. It is not like I have added the data in this table, but it is not present in another table. It is like saying there is author ID in table books, but actually the author ID does not exist only in the actual authors table. So MySQL ensures that it doesn't allow like that. Okay. And it can only reference foreign unique or primary key of the reference table. This is one thing. And also you saw, right? We had one author and he had a lot of books in another table. So the mapping between the tables was like one too many. I think this is pretty much here. Let us go to the next one. That is composite key. Okay. So what is a composite key? So let us say that we have some places where we don't want just one key as primary key or unique key, right? So we have more than one key, which together say that this is unique. Like let us say we consider a phone number plus email ID as unique for a system or for some use case. So then what will happen? Only if the phone number and the email ID is unique, then it will become a primary key. Then only we can insert. Okay, together combination of them being duplicate is not allowed. I think we have seen this example where we're specifying two columns together as unique or two columns together as primary key. Okay. I think there is nothing much in this also. You can just read through it. Okay. Yeah, I think everything is defined. And then we also have alternate keys. So it is just a definition. You just need to know the definition. There is nothing specific to saying there is no way to define an alternate key. So any key that is not a primary key, like unique and all we had, right? So all of them are called as alternate keys. That is the only difference between that is the only difference with an alternate key. It can also be called as secondary key or non-primary key. Okay, let us go ahead. So I just wanted to show you some table creations. So I'll just create this and show MySQL. So it's a very straightforward table. Here you can see what all special things do we have. There is a primary key, and then we have an auto increment. We have discussed what primary key is, what auto increment is. You can see there is this character size is 50, varchar 50. Email size is varchar 255. Unique means that you cannot have more than one value in the column, not null, created timestamp. I think it is very straightforward. Uh, I think I'll just go ahead. There is no point in repeating. If I find some special constraint, I'll just show that. Okay. So similarly, we have an employee table. So an employee table, employee ID becomes the primary key. You can have a first name, last name, email, salary, department ID, and you can see here, right? So foreign key, they say departments. In departments, department ID is the foreign key. I'll just show this example how foreign key would work. Okay. So let us say initially, if I say I am in company doesn't have it doesn't have department. Okay. So let us see if I do this. Okay. So let us say I do a create table, employee ID is primary key, and it says foreign key department ID. So here I've created department ID, right? We are saying this is the foreign key. And what does it reference? It references departments table. Okay. And the key in that table is department ID. So the column department ID in departments table is the foreign key here. So if I do a control enter, so what does it say? It is not passing. It is failing. Okay. So it is failing. It's saying failed to open the reference table departments. Why is that happening? That is happening because there is no departments table only. So uh, I'm using company table only. Just use company database. Okay. So if I try to create, it is not happening. So what do I need to do? I need to first create a department table. Let's say I create a department table. Okay. Create table department, and I have departments is a table name, and we have department ID as the key. It's primary, and don't want anything else. Okay, so let's just say department ID, and then I have department name. Okay. This much only. So now if I do a create on this, I'll remove this for a while. Okay, so now if I do a create, so this created a departments table, right? Now I can go and if you should be able to see here. So you can see departments table is created. It has one column department ID named int and primary key and name is of type varchar. The size is 100. Okay. So now I can create that employees table. So copy this. So if I do, let's say even if I give some other, if the column ID is wrong, right, it won't create. It will say fail to add the foreign key constraint. Missing ID column, missing column ID for constraint employee IB, whatever this is saying in the reference table. So what does that mean? It is saying the ID, the column name that you are given is not correct because that column name doesn't exist in this table departments. So what is the actual column name? The actual column is department ID. So let us say add a department ID. So now if I do a create table, you can see the create table has succeeded, right? 0 rows affected. The table has been created. So now if I can see on the side, there is employees and employees has a does not showing foreign key. Department ID is there and okay, foreign key is shown like this. So employees in employees foreign key, you can see employees IBFT. Okay. So this is a foreign key. So what happens if I try to create an employee where there is no foreign key existing at all? Like for example, if I do a select star from departments, right? So now if I run this, you can see there is nothing. It is empty. So now if I insert something into the employee, right? Insert into employees values. So what all are the columns? Employee ID. Let's say employee ID is 1. And then first name is, so what is the first name? First name is Adarsh. Adarsh, and then last name is Kumar. And email is, let's say, adarsh@gmail.com. Salary, let's say 1 lakh. And then department ID is 1. So now if I run this statement, you will see it will throw an error. See, cannot add or update a cannot add or update a child row. A foreign key constraint fails. Company employee. Okay. So why is that happening? Because we have not inserted anything with ID 1 in the departments table. So what do we need to first do? We need to first insert into the departments table, and then we need to insert this again. So what we'll do, insert into departments. Let us say values and ID 1 and the department name is accounting. Accounting department. Okay. So now I've inserted this. Now if I do a select star from employees, sorry, from departments. You should see the accounting department is there. Okay. So now I can add this thing. So now if I do a control enter, you will see insert into employees value 1 Adarsh Kumar, whatever. So, and if I do select star from employees, it will say that what 1 row returned, and it is showing that this row has been returned. Okay. So there is also one more thing. So there is this department ID 1, but what happens if I try to delete this department? Let's say from the departments table, delete from departments where ID is equal to 1. Okay. Sorry, department ID. See, right? What is it saying? Cannot delete or update a parent row. A foreign key constraint fails. So because there is a department, this department ID 1 is referenced in the employees table, I cannot delete this. But what if I delete it from that? What if I delete the employees from the table and then try delete from employees. Okay. So now I've deleted all the employees. Now if I try to run this command, okay, now it passes. Why is it passing now? It is passing because there are what? It is passing because there are no employees who are assigned to department number one. So because of that, I'm able to delete everything from the department from departments table. So now if you see, select star from departments, it should be 0. Okay. Hope this is clear. Somebody has a question. After creation, both two tables. After that, can we create foreign key? Uh, if you want to, yeah, you should be able to do it. So you can assign that this key is foreign key. You should be able to do that. We'll try that also. Okay. So let us say now I drop the foreign key constraint on this department ID table. Okay. So now if you see alter table name is what is it? What is the table name? Alter table employees. Okay. Drop constraint. So if you want to see what is the name of the constraint, right? You can see show create table employees. It shows you the whole command of the. So you can see here. So what would be the name of the constraint will be given here. Okay. I'll do Control C and 1 second. Notepad plus plus. So you can see the foreign key constraint is this employees IB F1K. So this is what is the name of the foreign key constraint. So I can drop this constraint directly. Alter table, table name is employees, and then drop constraint, the name of the constraint. Okay, so now you can see the constraint has been dropped. So now I can insert any random thing in employees table. Can do that. Insert into employees values. Wait, just do Control Z. I think I should get quickly. Okay, so we got this right. So even though there is no department to department ID 100, let's assume, but I'll still be able to add this value. Why? Because I have removed the foreign key constraint. Okay. So now if I want to create a foreign key constraint, let us try doing that. Okay, on the table, I should be able to do it still. So what we'll do, alter table, table name is department, no, employees, add foreign foreign key, and then on what do we what is the ID of the foreign key? It is same again, department ID. References. What is the table name? Table name is department. And then we have the column name, that is department ID. The column name is same here in both the tables. So now if I do this, and if I do enter, it will fail initially. Why is it failing? Fail to open the department. Sorry, it is departments. Okay. So even with this, it will fail. Why will it fail? It will fail because there is no department with ID 100, right? If you look at the employees table, I've already inserted. Select star from employees. See, I've already inserted a guy with department ID 100, but there is no department ID 100 at all. So if you remember, at any time, if I'm trying to add any kind of constraint, the columns should already, what do you say, should suffice that constraint. They should all follow that constraint, but it is not following. So what can we do? We can do one thing, that is we'll insert into departments value. Let's say ID is 100 and 100 says, let's say it is HR department. HR. Okay, so now if I insert this, so it has been added. So now if I try to add this foreign key, right, it will work. You can see, right, it has worked now. You can see the green thing. Alter table, it has worked because the reference that I had added is valid now because there is a row with 100 as the department ID and it all works properly. Okay. So if you are going to create a tweets table, so Twitter has tweets, right? So if you wanted to create tweets, how would you do? You would have a ID, which is the ID of the tweet that you can. You may not be able to see this ID, but inside the table it will be stored, and then we have the user ID. So basically, user ID should be. They've not added foreign key here, but user ID should be a foreign key value so that you don't, because how will you know which user ID? You should not be able to insert a tweet for somebody who's not there in the table only, right? The user ID should be foreign key. I think username also should be foreign key. They're not added varchar, not null text created it, location, language, retweet, unique. So see, they made unique as a column of a combination of two columns. Okay. Insert. I think nothing. You can just. This is just for your understanding. What all ways can we? What are the different ways of creating tables? Tweets. So somebody had asked me the other day, how would I insert images into a table, right? So one is you can insert the URL of the image. Here you can see I've created a table images and there is an ID for the image and you have a name and description and then you have the image path. So this image path can be anything that is present in, we usually don't store images in MySQL because MySQL is used for storing data. Data, you mean like it is used for storing anything that can be put in rows and columns, right? So images are not something that can be put in rows and columns. It is, they are like, you can call them, they're called as blobs. So it is better to store images and videos as a single file than adding them into MySQL. Okay. And MySQL and all, it is for very fast retrieval. Images, when you have the URL, you can directly retrieve. You don't need to actually index them and search them. Okay. So here I've just used the image path, but let us say if you wanted to store it as a blob, how would I do it? Okay. So this is one such example. So here you can see image type is blob. Okay, and it is not what do you say? It is not image path. If you saw here, the image path is a character, and here you can see image path is blob. It is not a character. Image type is blob, and then we cannot directly insert an image. We need to use a function called as load file. So just like how we had other functions, right? Reverse string or let's say uppercase, lowercase, and all. So load file is also a function like that. So what it does is it converts the image JPG image into blob format and then it inserts into the image table. Okay. So this is an example of a table creation where you have the key check constraint at the table level and not at the column level. And also you can see we are using two different columns here. Price is one column, quantity is another column, right? So there are two different columns that we are using to have a check constraint. If this was at a column level, then we couldn't have had two different column names used in the check constraint. Okay. So so here you can see, if you take, for example, let us say let's say this Amazon website. So orders belong to some customer. So there is a foreign key for customer ID and order also can be it is a product. So what do you order? Like, for example, let us say you're going to Dunzo and then you're ordering groceries. So every grocery has a product. It's a product ID. Like curd is one product, milk is one product. So all of them are product IDs. So whatever you're ordering, it should reference the product ID as well as a customer ID. Customer ID because which customer has ordered this order. Okay. So you can see the example here. Here we're having two foreign keys. Okay. And both of them have the tables and whatever ID are defined in their table. And also you can see in both the references, it is ID. But since it is belonging to two different tables, you can have the same name also. That doesn't matter. Okay. Then, so I think we had also discussed about enum types. So here we have created a country table called country, and enum can only be among any one of these, right? It can be any one of the 7 values. Okay. So similarly, this table is for showing what enum, how does enum work. Okay. Then similarly, another example of enum, again another example of enum where employee type can be manager, supervisor, or employee. Again another type with enum. Okay. So uh, I think we had discussed this also. Somebody had asked me, right? How do we add enums later point in time? So alter tables can be used to do that. You say modify and the enum, the column name, and then you can either add all the new enums or you can say just one single enum type. Like here, it was credit card, and initially, let me just show this to you. Orders table. No, let's go back. What is the orders table? Okay, 1 second. So let us say I have orders table. The table is created. So now the payment methods are only 3. If I try to add the fourth, any other payment method, it will fail. Okay. Like for example, we do insert into orders. And then if I do values, and let's say ID is 1, order date is, let's say 2022 12 and then payment method is, let's say it was wallet. Now it will fail saying we don't have that payment method at all, right? So data truncated for column payment method at row 1. So now I can either add the value via modify column, or you can do add enum. So I think we have tried modify column, we'll do add enum. Okay. Alter table orders, and we say add was the syntax. Syntax was uh, modify. Okay, so it was modify to column name and add enum add. Okay. Modify column name should be payment method. And then add enum. Functions add enum add, sorry. Enum add. Then you have the type of the enum. Say by to wallet. Okay. Why is this still? I think they are not supported for that. Okay, I think this is not supported in my version of MySQL. Version of the right segment and one line to value at this position. It's okay, fine. So we can do it the other way. You have the column name and you specify all the enum types. Enum, and then you do all of these. You also say wallet. Then when I do an enter, it has added this. So now if I run this, it will work fine. Okay. This was for enum example. Then what else? After this, again, same foreign key. We have discussed books and authors. Similar, we discussed, I think, similar one. So whatever constraints that you have discussed, they can be grouped into these 3 different types. So one is domain integrity. So domain integrity constraints is for specific column. Okay. So like I said, a column cannot have null values. A check on column saying the value should be always be greater than size 18. Okay. So all these kind of constraints are called domain constraints. So that you maintain a domain is like a column is called a domain, a variable type with certain specific extra conditions. Like you had, let's say int, but also on top of that you have that it should not be null. It should not be its value should not be less than or greater than this. It should satisfy all these criteria. So all of them come under domain integrity. Okay. So under entity, what does entity integrity mean? Entity integrity means it is related to the number of items in the column. So let us say in a column, we don't want anything to have, what do you say, all the values to be unique. We don't want them to repeat. So that kind of a constraint is called entity constraint. Okay. And what is referential constraint? So when we are referring one column in one table, one column from a table into another column, when we had foreign key example, right? So in foreign key, we were referencing a column from table books, a column from table author in the books column. We are using the author ID. So similarly, so there MySQL ensures that you are not allowed to delete the author without deleting all the books, or you cannot add a book with an author which is not present. So all of those kind of checks and all are done by MySQL, right? So those kind of constraints are called referential integrity constraints. Okay. Uh, Nothing to whatever we have learned, it is just grouping them into different concepts. Okay. And I think we also looked at a lot of examples of filter tables. So I'll skip this. This will be there in the slide. So if you want to look at this, you can look at it afterwards. Okay. The table. And also, let us say you wanted to add a new column or delete or rename a column. Okay. So there are ways to do that as well. So how do you do? You have alter table and add column. So whenever you're adding a column, right, there are a lot of options. That is, you can either add a column after some other column, or you can add it in the beginning. Okay. So that is defined by saying first and after. So if you say first, this column becomes the first column. If you say after some column name, then it will be in between that column name and the next column name. So let us say which column table do we want to take? So let's say we have employees. Okay. Employee ID is their first name, is their last name, email, salary, department. So let us say now I want to add a address column, alter table, table name, does the table name employees, and I say add column, column name address, and all the properties of the address. It's varchar and size is 100, and let's say it's not null. Okay, and after let's say we wanted to keep it first itself. Okay, so now if I do first, this will be added in the very beginning. If you see employees currently, employee ID is first, right? So this will become the first column. Okay, so now it has become the first column. So now if I refresh this, we should see address. So address has come even on top, right? So if I do select star from employees, the address column is always shown at the beginning. Okay. So not null, it has come empty. Yeah, okay. Fine. So now let us say I wanted to add one more column after after, let's say I wanted to add it after email, and we'll call it city. Okay. So then city and varchar 100. Let's remove not null. And let us say it is after email. So now this should also work. So now what has happened? It has added the column city and after email. If I do a refresh, city. Okay. City has been added. Now if I do select after employee also, city will come after email. Okay. Cool. Let us go to the next property. I think same thing. You can also change an existing column name. So here we were adding a new column. Here we can change the column name from old column to new column. Okay. This is just rename column name old and to new one. I think we discussed this yesterday only. Can we create a new table from the existing one? Yeah, it is possible. It is possible to create a new table from existing one anytime. You just do create table and then the name of the table. Let's say it's employee 2, select star from employee. Okay. What happened? Company.employee employees. right? So now what happened is we have created a table named employee two. If you see the employee two structure, right? Uh, so let's start from employee two. So you can see the same table is copied into another table. All of this there. If you want, you can remove everything also and then add. Okay. So it is possible. Address column should be present after email column. Changing the location that I am not sure. Hmm, change column. I think it should be able to do it. Let's just try. Okay. Let us say I had so alter table instead of add column city. Sorry, so alter table and table name is employees. And then what is the syntax? The syntax is change column. Okay. Change column, column, old column, new column name. But we'll still have to give the column definition. Change column, let's say the name is address, and new is also address only. And let's say its data type is varchar 100, and it was not null. And let's say it is after email. Okay. So now this has changed. So now what if I do select star from employees, address has come after email. So yeah, it is possible. Okay. So let us go ahead. And this is all, it is like, reading things in English. So what am I doing? Alter table, this table name, change column name from this column name to this column name. First, keep it first or keep it after. Most of the SQL, right? You see, select this from this, where this is this, greater than this is this, smaller than this, that. So it is, so SQL is like very, it is very easy to learn because most of the queries, even if you don't remember, right, you can just try to say what you want to do in English. So I want to delete a table, delete from table this, let's say where this and this. So if you're able to just tell what you want to do in English properly, right? First, what if your requirement is clear, what I want to do, then it is as simple as little bit syntax modification here and there, but it is like just telling it in English only, not much difference. Okay. So let us go ahead. I think not much, not much. Mm. Hmm. So whenever we are deleting a column, I didn't show how to delete a column. It is also very simple. You just say drop column, whatever is the column name. But whenever you are deleting, there are a lot of things that can happen. Like let's say if you've done some, if you have created a stored, if you have created a trigger, or if you have created procedures or views on base that table, right? They will also go away. And also, if you have added this column at a lot of different places, and if you delete here, right, later on you'll not be able to see this column, and you might have to do a lot of code changes and all. Okay. And also, whenever you're removing a column, there is a lot of because let's say the size of the table is there are 1 million rows. So it's like you're removing 1 million items from a table. So it also takes a lot of time. Okay. So now we come to truncate table. So I think a lot of people had what is difference between truncate table, delete table, not delete, delete from the table and then drop. First of all, let me show you what truncate does, then I'll explain how it does it. Okay. I think I had shown how what truncate does some time back. I'll do it again. So let us say you had so this is the table, right? Employees. Select star. No, this table is having a lot of data. It doesn't have much data. So let us say I had a student one would have data. Select star from student. Thing is there student one. Okay, student one has a lot of data, right? I'll copy this into one more table. Create table student two. Select star from student one. I think I created student two table. Let us do student three also. Okay. So now from student one, I'm going to drop all the rows, delete all the rows. So how would I do that? delete star from student one. Okay. No, delete table name. Delete from student one, not star. Delete from student one where we would. Let's say I'm not putting any condition. So then what will it do? It will remove all the rows from the table. So you can see 64 rows affected. So 64 rows were removed. So now if I do select star from student one, so you see there is nothing. Okay, it's empty. So this is one thing. Delete we are done on student one. Let's do truncate. Truncate table. I think it's just truncate. Okay, student two. So what it has done? So you can see the difference here, right? So delete from student one, it shows 64 rows affected. But truncate student two, 0 rows affected. But if I do select star from student two, the empty student two, it is empty. So this table is this command, delete command, it is saying 64 rows affected. So it is saying 64 rows are deleted. And how much time did it take? It took 0.016. But truncate has taken more time here, but okay. In bigger cases, it is different. But if you see truncate student, it says 0 rows affected, but delete student, it says 64 rows affected. Why is that? We'll discuss. Okay. And we are seeing delete and truncate. And if I do drop table student 3, so drop table is also saying 0 rows affected. But if you see, right, drop table actually deletes the whole table. If I do select star from table student 3, that says table company student 3 does not exist. Okay, so differences, we saw what each query is doing. Now we'll see how it is doing that. Okay, okay. So now let us assume this was a table student one. Okay, so now if I do say it has all these columns, it has ID, name, and then some value. Okay, so this table is named student one. So if I do delete, right? Delete from student one. So this will delete all the rows. But what happens is it will go to every single row and it will say, okay, you are deleted. You are also 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 deleted. So this is what delete command does. Okay. So that is why you are able to see it is saying 64 rows affected. So it went to each and every single row. It went and touched each and every single row. I told, okay, you're deleted. You're deleted. You're deleted. How it does that delete? No need to know now, but it just removes. So it removes, it goes and touches every single row and removes them. So this is what delete command does. But what does truncate do? So let's go to how truncate would do it. Okay. So what truncate does is truncate creates a new table altogether. Okay. So let's say what it does, it creates a new table altogether. Let's say, okay, black. Okay. It creates a new, one second, creates a new table. Say it is temp one with all the properties similar to this table. Okay. Whatever the properties, it creates the same table. ID, name, let's say it was class, and let's say it was marks. So this will create same class, marks. But what it doesn't do is it doesn't copy all this into this new table. Okay. So it is not copying anything. It is just creating a new table with the same schema. Then what it does is it switches this pointer. So this student is pointing to this table, right? So it removes this pointing and it points to this and it renames the table. Okay. So now what happened? Instead of deleting all the rows one by one like this, like this, like this, so it just, instead of pointing student one to this, it started pointing student one to this. Okay. This in the background will get deleted after some point of time. Okay. You don't have to worry about when it will get deleted and all, but this will get deleted and erased after some point of time. But for us, the student table is very free, and quickly it has become empty and it is free. Okay. So in both the cases, the rows in the table became empty. But in the first one, what happened was we went to each and every single row and touched the rows and removed the rows. But here, what happened? We just created a new table. We created a separate table with the same schema, and then we renamed it to student one. Drop table is again different. So drop table, what it is doing, it is actually removing the whole table only. So in this, the schema also won't be present. Nothing is present. It is totally erased from your database. In delete, in truncate, delete, it depends. If you delete all the rows get deleted, or else you can only delete one or two rows. But in truncate, all the rows get deleted. In drop, the whole table only gets deleted. Okay. So I hope this is clear. If you look at the presentation, you would see that. So there are a lot of things because we are just directly second. Because you're just directly renaming from, like, let's say the pointer is pointing to this table, and then we say don't point here, we point here, right? So there are a lot of things that we miss out when we delete. Okay, I'll just explain you what are those things. Okay, so it is used to remove all data and reset the auto increment value, and its delete is faster. Why its delete is faster? Because they are not actually deleting. It is just renaming the table. It is just renaming it from one table to another table. Okay, and also because we are not touching all the columns we are not touching all the rows one by one. There are things called as trigger. So let us say I wanted to execute a statement after every single what do you say? Let us say I wanted to execute a statement after every single row is deleted. Like after one row gets deleted, do this. After one row gets deleted, do this, like that. So now what will happen is all of that won't be done because we are not going and deleting every single row. That is one thing. And also when we learn about this transaction control, right? We'll see how to roll back a transaction and all. So that is also not possible when we are doing truncate. Okay. If a table has foreign key, right, you cannot do truncate table because when you do truncate table, it might happen that you'll delete all the rows without even checking whether one is existing or no or that. So you can't do it on a foreign key reference, and it is faster than delete because it doesn't do a lot of things. Basically, we'll see why and what, but it doesn't do a lot of things. Okay, and it is used to empty a table quickly and efficiently. I'll repeat one more time once I go through the differences and all as well. Okay, so you can see the differences. Language, the command that is no, not the category to which it belongs to. Uh, delete is data manipulation because we're manipulating the data, whereas drop and truncate both are data definition because we're actually creating a new table in truncate and we are removing the whole table in drop. Both are data definition language. Okay. And delete command is used to delete one or more rows, whereas drop command is used to delete the whole table, and truncate is used to delete all rows and then create a new table. Okay. Transition. So rollback is a command that we use when we are looking at transactions and all. So rollback is not supported in truncate. Okay. And memory space, like I told you, right? Truncate doesn't delete everything very fast. So it deletes, it looks like it has deleted it fast, but in the backend, it is still there. So it takes a little bit time for all the memory to get freed. But whereas in drop command, right? In drop command, the whole memory and space is released. Delete command, I think it does not free the allocated space, the table. Okay. Okay. So delete keeps that space. It can be used by some other uh, row that we're adding afterwards. Okay. Performance, truncate is actually faster, but it is faster because it skips a lot of things. Integrity constraint. In delete and truncate, they're not removed. But in drop, because everything is deleted, the whole table is deleted, it will get removed. Okay. Permission, you need delete. In drop command, you need alter permission. Okay. And here also in truncate, you need alter permission. Alter because again, you are deleting one table and creating new table and all, right? The syntax is straightforward, whatever we saw. Okay. Oh, sorry. First, let us try to discuss why do we need joins? Okay. So we had this thing, right? We had a table of books and we had a table of author. And we said we don't want to keep all the information everywhere. Like I don't want a book name and all the details about the author here only. Author name, author age, everything I don't want in this table only. So what we decided? We decided so we'll only have one author ID here. Okay, and we'll have book ID here. And we'll have author's data in different table. Author name, his details, age, city, and all. Okay. But now, how do we, let us say somebody comes afterwards and says, get me all the books written by Amish Tripathi. Okay. So let's say the query is get me all the books written by Amish Tripathi. So here, you know, what is the name of the author? You know the author name Amish Tripathi. So you'll find the author ID. Let's say it is 2. So then you'll come to books and you'll search all the books that are given to me by written by Amish Tripathi. Okay. But to do this, to join, to get the just using the name, to get the ID and then match it with this table and then get all the books, right? So what do we need to do? There we need to do joins. Okay. So basically we are taking two or more than two tables and then we are finding a common column between both of them. So here, what was the common column? The common column was author ID, and here also the common column is author ID. So this common column means something, right? It means that it's like a mapping. So so whatever is the author ID here, name. So I've just added it here. So in case you want to find out data about this author ID, come to this table and search. Okay. So this is what we do. We join both the tables and we join using a common one or more than one common columns. Okay, that is what is join. And not only for this, let us say now somebody tells me, see how many books were sold by American authors. Number of books sold by American authors. So now I separated both the information. So in this table, I only have the author ID. Okay. So how do I know who all are American authors? So I have to come to this table, authors table, and see in the address. So I would have, let's say I added country. Okay, so in this country, it is America, let's say. So I'll see all of this. So then what I would do, I would find all the authors whose country is America. Okay, all the authors whose country is America, and then take all these numbers. Let's say it is 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7 people were in America. Then what I would do? I would add all these IDs and I would check where author ID is in 2, 3, 4, 5, 6, 7. Okay, and then this would give me all the books which belong to American authors. Okay, so there are a lot of places where we want to take data from 2, 3 different separate tables and add them into one table. Okay, that is when we use joins. What screen did I press? Okay, that's correct. So why do we need joins? One is we want to combine data from 2, 3 tables and then show at a single place. Okay, and we might want to take a common column which is present between 2, 3 tables and use it to get some data. Before going, there are 4 types of joins. I'll tell you what each of them. First is inner join, the other left outer join, right outer join, and full outer join. So full outer join is not supported in MySQL by default, but we can achieve it using two, three different queries together. Okay. What is inner join? We'll look at it first. Okay. So let us say you have two tables, table 1 and table 2. Okay. So based on some common criteria, there would be rows which are which match a condition in both table 1 and table 2. Okay, the green category that you see. So this data that we get from joining is called inner join. So because it is common in both table 1 and table 2, it is called inner join. Okay, so if you look at the syntax, you can see here, select column names from table, the column name and names. So it can be a column from, so because a table, a join has more than one table, right? So it can be one or two tables or more. It can be, it is always more than one table. You can have a join with one table also, but even there are one or more tables which are participating in the join. So you have select column names, name or names, and then table one from table one. So inner join on which table you want to do table two, and then the condition. So what is the column common column between both the tables? Okay, I'll show examples when I'll show examples. I just want to show you the syntax now. Okay, so on table one, let's say table one column name is some random ID, and table two also column name is ID. So then what this will return is, this will return as all the uh, columns from both the tables, table one and table two, which match this criteria. Okay, so let us take a look at and show you some examples. So there's a table that comes with by default with what do you say? MySQL. When you install MySQL, you get world table. So it has city, country, and country language. So if I show you city, select star from city. Okay, so if I do, okay, we have to use database first. Use world. Use world. Select star from city. Okay, so let's say you have all of this. Okay, so the country code, city should have some foreign key. City has a foreign key. City has the given. It is on country code. Okay. So now let us say I don't know what is the country code of India. Okay. And I want to find all districts that are present in all the districts that are present in India. So how I would do? So if I go to country table will have, if you see country, right? Country will have the country name. Select star from countries. It's country. Okay. So it has all of this. Okay. So now what I can do, I will do select, let's say district. The name was district, right? City name was district. Select district, comma, country code. I should define country code, comma, what? Let's say population, comma, country name. Okay. So name, there are, I'll tell you, I will see from, we want to combine city table with country table, right? From city, inner join on the table name that is country on, say, city dot country code is equal to, what do we have in country? Country dot code. Okay. And where country name we have, right? Name is equal to India. This should show me all the districts from India, but there are a lot of errors. So what are the errors? I'll tell you. Okay. So first thing, what do you see? You see that there is name and city as well, and then there is name in country as well. So how do we differentiate between what this name means? Is it city call table name or is it country call table name? So that we do it with the table, whatever is the name of the table first. Okay. So let's say I do city dot name. So this means show me the column from city table. Okay. If I would do country dot name, it would show me the column from country table. And if I want both, what would I do? I would do city dot name, comma, country dot name. Okay. So I wanted the country name to be India, then I what I'll do where country dot name to be India. Okay. So now you can see we are selecting district, and because district is not present in this, right, in country table, I can just say direct district. So it is only one, so it will take from this. Country code is present in what both the tables. Yeah, country code. The country code is not present in both, so that is also fine. Population is only present in this, or it is present in both. So should say what population I want. Let's say I want city dot population. We'll do city dot population, city dot name, and country dot name. Okay. So from what is the first table that I want? I want to join it on which table? On country, such that both the code on both sides should be same. Okay. And where country is India. So now if I run this, so you can see this will only show me all the districts that are coming from what do you say? That are coming from wherever the country code is IND. So did I know what is the country code of India IND? I didn't know. So what I did, I fetched it from country table. Okay, I'll show one more example. If not, we'll end for today and we'll discuss tomorrow. So I have two tables here. Okay, so in joins two. So one table is employee, and employee has column ID, name, department, salary, gender, age, city. So if I do select star from employee, so you can see 1001 John Doe, department, salary, male, gender, city, and all. Okay. And does it have any foreign keys? So there are no foreign keys. There is one index primary. Okay. And then they have projects. Okay. So what does project look like? Select star from projects. Okay. So we have project ID and we have uh, title of the project and client ID and employee ID. So you can see what is common between both the tables. Employee ID is common. Okay. So I think you can see now. Okay. So if you see select star from projects, there is project ID, title, client ID, and employee ID. Okay. So this table is for projects. What are the projects? And this table is for employees. Who all are the employees? So now let us say I want to find out. Control enter. So this table is for employees. I want to find out which all employees belong to what all projects. Okay. So then how would I do? So then what I have to do, I have to find what is the common column between these both tables. So you can see here, project has foreign key. What is the foreign key? The foreign key is on employee ID table, employee. ID column on employee ID table. Okay. So now then what I can do, if I wanted to find out all the projects, then I'll do this. So I'll do a join on both the tables. On what column? On employee ID column. So what I want to find out what is the project name that each person is working on. So I'll do select first, find the ID of the employee. So let us say I will take the select from let's say employee table name is employee as E, inner join table name is projects as P. So I want the name of the employees, ID of the employee E dot ID, and then I want the name of the employee E dot name, and then his department E dot department, and I also want the columns from the project table. So what are the columns? Say I want project ID and title. Okay. So what I'll do, P stable, P I refer to it as project stable, I refer to it as P. So I'll do P dot title. Okay. And then P dot client ID. Okay. I think let's this much enough for now. So inner join projects as P. On what do we want to join? What is the common column between them that we want to equate both to? So that is E dot employee ID is equal to P dot, what is the employee ID in project? So it is P dot employee ID directly. So it will be P dot employee ID. Okay. So now if I run this, so can you see it shows all the columns that are requested for, and the employees who are belonging to any, what do you say, what, who have projects assigned to them. Because if you see the total number of employees here, how many rows are there? We have 10 rows, 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. But how many total employees were there? Select star from employees. What happened? Employee. Okay, so there were almost 10 employees. But when I did this, I only got 8 people. So why 8 people? Because only 8 people were assigned to any projects. Okay. Some people were not assigned any projects at all. If you see projects table, right? Let's start from projects. Let's take, for example, 1, 2, 3, 4, 5. Employee number 1005. Okay. So employee number 1005 is Linda Jones. Okay. And let's see if Linda, how do we check if Linda Jones is assigned some project? So we go to select start from projects. So do you see 1005 anywhere here? There is no, right? Null, null, null. 1, 2, 3, 4, 7. Okay. So employee number 5 is not assigned any project. So that is why when I run here, so there is nothing which is showing up. Okay. So only if the condition matches on both the tables, these are shown. Whatever is not matching, right? If it is empty, null, or anything, it is not shown. Okay. So that is why we have 8 people, and you can see we have got the title of the project. Explains or still, we'll do one thing. We'll stop for today. I'll continue tomorrow with again joins. We'll look at some lot of examples. We'll try to, we'll just dedicate to joins tomorrow, and we will see a lot of different examples, and I'll help you understand. Okay.